Time is a word we use casually, yet it stretches into something so much larger than our ordinary lives. For when we listen carefully, we notice it slipping, folding, and bending in ways that do not obey simple clocks. The feeling of time is usually steady, like a heartbeat or a tick of seconds. And yet the deeper we move into the universe, the more unstable this feeling becomes. Close to extreme places, time itself refuses to behave as it does in the quiet of our daily world. It begins to stretch like fabric, to slow like breath, to stagger as if pulled by invisible hands. The truth of time's nature is never more vivid than when we speak of a black hole. For there, the familiar rhythm of seconds breaks into something almost unimaginable. Welcome to the drowsy astronaut, a calm place to leave behind your weight, where we do not rush through answers but instead let them flow at a pace that lets the mind rest. Here, the journey is never about memorizing facts, but about feeling what those facts mean, the way water feels on your skin, or the way silence deepens at night. Together, we move gently, looking at the deeper parts of the universe, because only when we slow down do the larger patterns begin to reveal themselves. I wish you a steady passage through these thoughts, a passage that lets you drift into rest if you choose, or remain awake while your mind roams far. Black hole is a name that hides both simplicity and mystery, for it is nothing more than gravity gathered until it bends light itself. Yet it carries the heaviest paradoxes of time. A black hole does not let signals escape, not even a photon. But to understand what this means, we must first remember how gravity and time are woven. Einstein showed us that space and time are not separate, but instead are a single fabric, a sheet that bends whenever matter or energy press into it. The closer we are to heavy mass, the slower time runs, and in a black hole, this principle is drawn to its extreme. Imagine a clock far from a planet, ticking at its usual rate, and another clock resting deep in a valley of gravity. The clock in the valley does not break, nor does its mechanism falter. Yet, to the distant observer, its seconds slide slowly, stretching away from normal rhythm. Now place that second clock near the rim of a black hole, and the distortion grows so immense that the two clocks no longer agree at all. The observer far away might watch years pass while the local traveler sees only minutes. Both truths correct, each tied to their position in space-time. To us, this difference is hard to feel, for on Earth the effect is subtle, measured only in the faint precision of satellites. The GPS satellites orbiting overhead actually tick faster than clocks on the ground. Not by much, but enough that without correction, navigation would collapse within hours. Gravity slows time just slightly, even on our familiar planet. And so engineers must blend relativity into every calculation we make. This tiny adjustment is a reminder of the greater truth, that time is not universal, but always relative. Near a black hole, relativity is no longer a small correction. It is the dominant experience. The astronaut falling inward would feel nothing unusual with their heartbeat, seconds arriving as they always do. Yet, to an outside observer, that astronaut would seem to slow, their movements stretched thinner and thinner until almost frozen. The signals of their voice would grow long, red, and dim until only silence remains. From the outside, the traveler never quite reaches the horizon, their image lingering as if stuck at the edge of eternity. The truth is different from the traveler's own view, for in their frame they cross the horizon without pause, without resistance. Both realities are true, each a faithful account of time from its own perspective. This is the heart of relativity, not contradiction, but coexistence. The black hole teaches us that perception and reality are bound by frames. No single clock rules them all. Think of the emotions such a distortion might cause. To hover near a horizon is to know that distant centuries are racing past. The astronaut might stay only an hour by their reckoning, but when they return outward, civilizations could have changed. In that short stretch of their own time, entire histories could unfold beyond their reach. The weight of such an experience makes time feel less like flow and more like a landscape stretched across perception. Even language bends under these ideas, because our words for past, present, and future assume shared rhythm. The moment you call now is not the same for another observer, if they stand at a different depth of gravity. Past and future blur into questions of where you are, not only when you are. The frame of reference reshapes what seems to be an absolute truth until we must accept relativity as our guide. Closer still, the differences grow so vast that one can imagine a traveler seeing the universe accelerate around them. The outside sky might seem to hurry, galaxies spinning through epochs in what feels like moments. Meanwhile, their body, their thoughts, their own clock would feel normal, steady as always. The contrast is breathtaking, for it reveals that time is not uniform, but deeply personal to position and motion. Why does this happen? Why does gravity touch time when it seems like a force that should only pull? The answer lies in the curvature of space-time, where mass warps the very metric by which seconds are measured. Instead of pulling alone, gravity is the bending of geometry, making all paths curve inward, including the path of time. The traveler near a black hole is not broken or damaged, but their time is stitched differently into the cosmic fabric. Even light itself is slowed in its climb, stretching wavelengths until they fall beyond visibility. The closer a photon is borne to the horizon, the longer its climb, the redder its hue becomes. To the distant observer, that photon may take forever to arrive. Though for the photon, its journey is without time at all. The lesson is that time and energy are linked, each shift a mark of the gravity they endured. Scientists test these principles not only through thought, but through measurement. For time dilation is no longer only a theory, but something confirmed in orbit and in labs. The clocks placed on airplanes or satellites tick differently from ground clocks, and every careful experiment matches Einstein's predictions. Even particles in accelerators prove this, for their lifetimes stretch, racing near the speed of light, surviving longer than they would at rest. The effect is subtle here on Earth, but it is overwhelming at a black hole, where seconds can separate themselves into centuries. Imagine two explorers who choose different paths, one circling close to a black hole, the other drifting farther away. The one in orbit feels time normally, counting minutes, while to the distant partner, those minutes are stretched into years. Reunion becomes strange, for when they meet again, one is older, though both believe they lived the same span. The paradox of twins divided by gravity is no longer a puzzle, but a prediction, one already tested in milder forms above our Earth. Stories of relativity often sound like fiction, yet they are the geometry, written plainly into the mathematics of space-time. The lines drawn on Einstein's equations describe every possibility, not as guesses, but as structures more reliable than stone. Every experiment has pressed against them, yet they do not bend. Instead, they prove again that nature is stranger than belief. The closer we listen to their implications, the more clear it becomes that time itself is not the steady stage we thought. Inside a black hole, our mathematics falter, but just outside the horizon, relativity reigns unchallenged. The traveler sees no drama at the instant of crossing, their own watch ticking as always, their heartbeat still faithful. Only the distant viewer marks the edge with a freeze, signals stretching until they vanish altogether. The contrast between views is not error, but truth, each perspective bound by the path it inhabits. Think of light trying to escape from that edge, climbing endlessly yet losing energy in the process. The redshift grows until wavelengths swell beyond any instrument, the glow fading into darkness though it never truly stops. From far away, the last rays of the traveler's signal are stretched thin until they blur into silence. The story of the fall remains written, but it is written into darkness, where no eye can recover it again. Philosophers ask what it means to speak of now, when every observer holds their own separate stream of moments. The word present feels shared, yet relativity denies such agreement. For gravity alters rhythm as surely as speed does. On a train rushing forward, time itself is different, and even more so at the lip of a black hole. The paradox is that our language demands one truth, but the universe offers many truths at once. Every image of time we hold is shaped by Earth, where gravity is gentle, where speeds are slow. The moment you feel is a product of this stable frame, but beyond it, the rhythm begins to slide. Elsewhere, seconds are not uniform, they are personal, altered by position and motion alike. The cosmos insists that time is not absolute, but always relative, bent and reshaped by the company it keeps. Near a black hole, relativity moves from subtle to spectacular, pulling the curtain back on what space-time truly is. The astronaut who hovers there lives in their own bubble, each moment faithful to their own pulse and breath. Meanwhile, the universe above them rushes on in fast forward. Stars aging, galaxies colliding, histories written and erased. The realization is humbling, for it means no two places share the same unfolding, each has its own script. Even the stars themselves whisper proof of this stretching, their light redshifted as they fall toward our view. The spectrum of hydrogen, of helium, of simple atoms slides into longer colors as though painted with a moving brush. Telescopes measure this shift and confirm the pull, the bending of time as light struggles upward. The evidence is constant, and it tells us that time is always tied to the gravity of the place it inhabits. Some wonder what time would feel like if you could hover, balanced by rockets above the horizon, holding position. The astronaut there would see the stars above race, while their own seconds crept along more slowly. Every heartbeat would be normal to them, but outside, decades or centuries could have unfolded already. The black hole offers such scenarios freely, not as imagination, but as the true working of its field. Even in story form, this idea carries weight, for it tells us that to touch a black hole is to touch eternity, the difference between one traveler's clock and another's calendar. becomes so vast that return is impossible without paradox. To leave such a region is to find yourself displaced, as though the rest of the universe had hurried past. The feeling of such a fate is both haunting and beautiful, for it makes us realize that time is not ours to command. Across human history, we measured days and seasons, the slow turning of Earth giving rhythm to our existence. The sundial and hourglass gave way to mechanical clocks, then to digital precision etched into silicon. Yet, no matter the tool, the truth remained that these are only shadows of the deeper flow. The cosmos does not honor human divisions of hours, but instead stretches and twists them according to gravity's will. Closer to understanding, we find that time is as much experience as it is measurement. The feeling of an hour waiting is not the same as an hour in joy, yet both are equal on the clock. Relativity reveals that this is not just psychology, but physics itself bending what duration means. The truth is that each of us already lives in a personal stream of time, though on Earth those differences are small. Near a black hole, those differences become absolute, turning human intuition upside down. The mind struggles to grasp how seconds can separate, leaving one observer young while another is old. Only by slowing our thinking do we sense that this is not magic, not illusion, but the geometry of space-time itself. The lesson of the black hole is not destruction alone, but revelation of structure, that even time is pliable under gravity. Relativity tells us that gravity and speed are twins in shaping time, and nowhere is this clearer than in the orbits around a black hole. The closer an object spins near the edge, the slower its moments, because velocity and gravity conspire together to warp seconds into something foreign. Satellites around Earth prove this already, their signals drifting in pace, corrected constantly to align with the ground clocks below. The scale is small here, but magnified at a black hole, it grows into eternity. Minutes versus millennia, breaths versus empires. Imagine a spacecraft holding a tight, circular path, skimming the event horizon but never crossing inside. The crew aboard would feel time running in their ordinary rhythm, unaware of the distortions seen beyond. Meanwhile, to a distant watcher, their lives would appear to drag. Days stretched into years, movements delayed into silence. The gap between these views is not illusion but fact, a direct result of the fabric of space-time curving on itself. Physics assures us that all frames of reference are equally valid, but this equality reveals how strange the cosmos truly is. The traveler circling near the horizon sees their watch ticking, steady, honest, unchanged. Yet, the galaxies beyond them are racing in fast forward, showing them futures compressed into mere heartbeats. The paradox is that neither view is wrong, both are tied to position, the very ground rules of relativity itself. Closer we move in thought, and we find that energy plays its part, because as time bends, so too does the flow of motion. The orbit of matter near a black hole glows with friction, as atoms are torn and heated to violent radiance. Observers see this as a blazing disk called an accretion disk, burning brighter than galaxies across vast distances. The fire of these swirls is also bound by time, for each photon leaving them is delayed, redshifted, bent. From far away, the disk seems to shimmer, slowed as though playing a cosmic film at half speed. The light leaving those orbits is stretched in frequency, coloured by the tug of gravity. Each signal is a story of struggle, a climb, as energy works upward against the pull. The image we capture is already altered by time, carrying the mark of relativity in every wave. Technology now allows us to glimpse these regions in detail, most famously through the Event Horizon Telescope. The first picture of a black hole's shadow revealed a glowing ring, photons bent into an orbit by sheer gravity. Every pixel in that image carries distortion of time, signals delayed, frequencies stretched, paths curved. The truth of relativity is no longer abstract, but a portrait, painted directly onto our telescopes. Consider the human scale of such knowledge, for we live in hours and days, yet here we measure billions of years. The stretch is nearly beyond imagination, but it is real, confirmed in equations, seen in radiation. Even Einstein may have marveled at such sight. That mathematics once confined to paper is now visible as light. The journey of physics has been one of patience, of following time itself until it revealed its secrets. Imagine again a traveler who dares to descend toward the horizon, guided by engines strong enough to resist. The astronaut measures their heartbeat, their breath, their seconds, each one familiar, each one unchanged. Meanwhile, the universe beyond them is racing forward, stars shifting, galaxies colliding, civilizations vanishing. The gap is unbearable to picture, yet it is the real outcome of time stretched by infinite gravity. Even science fiction has embraced this idea. The notion of explorers returning home to find the world transformed. The story of twins divided by space and motion. One aged, the other still young, is no longer fantasy. Relativity alone is enough to carve this difference, without magic, without exaggeration. The paradox becomes human when we imagine faces, families, histories, all separating under the hand of gravity. Closer still, one wonders what consciousness would feel, caught between a personal flow of time and a cosmic storm outside. The traveller inside would not sense slowness nor delay, their mind unbroken, their body unchanged. Only the return outward would reveal the truth. The gap between their lived span and the ages past. The cost of such exploration is measured not in energy, but in separation from everything once familiar. Philosophy meets physics here, for we are forced to ask what now truly means when no agreement can be shared. The present of one traveller is the deep past of another, and the future of yet another. Time becomes less a universal river and more a patchwork, stitched together by perspectives, each complete but not overlapping. The truth is both comforting and strange, reminding us that the cosmos is not bound by our habits. Even memory must be rethought in this context, because memory assumes a shared order of cause and effect. The sequence of events is not fixed across frames. One person's cause can be another's effect. Near a black hole, even the idea of simultaneity collapses, leaving us to redefine what order means. The cosmos resists our simplicity, pushing us toward deeper understanding, with every paradox it shows. Some physicists wonder whether time could be reversed, whether in theory an extreme might play it backward. The mathematics does not forbid the idea of symmetry, but entropy, the arrow of disorder, resists it. Black holes seem to end that debate, for their gravity makes reversal impossible beyond their edge. The The flow of time there is one way, into collapse, into silence, where information itself struggles to survive. Even Hawking radiation tells us that time in a black hole is stranger still, for evaporation bleeds it away. The particles emerge faintly from the vacuum, tiny signals leaking from the horizon. Over unimaginable spans, a black hole shrinks, until at last it fades, returning its mass to the void. The process is slow, but it insists that nothing is permanent, not even the great engines of gravity. Closer, we lean to the question of what time feels like inside, beyond the horizon, though no signals ever return. The mathematics falters there, offering singularities and infinities, edges where equations collapse. Some say new physics must take over, that quantum gravity will one day replace these infinities. The truth is unknown, but it forces us to expand our language, to admit we do not yet understand. Imagine yourself at the edge of such a place, seconds steady, heart unbroken, thoughts moving calmly. The outside universe watches you fade, your light, stretching into endless red until silence holds it. From your view, nothing has changed, yet the gap between you and them has become immeasurable. The feeling of such a fate is beyond our daily senses, but it is the logical extension of relativity. Every thought experiment of Einstein becomes alive at a black hole. For trains and clocks are replaced with stars and galaxies, the principle remains the same. Time is tied to motion, and gravity is simply curved geometry. Even the smallest experiment echoes in this truth, that no clock stands outside the fabric it inhabits. The lesson is profound, showing us that time is not absolute, but as shifting as the space it fills. Slowly, we begin to see why people speak of black holes with awe, for they are not merely destroyers, but teachers. The paradox of freezing and falling, of aging and pausing, is not contradiction, but perspective. Every observer carries their own measure of time, and every one of them is correct. The realization is humbling. No truth stands above the others. Each is written by its own path. Here we pause our descent, having traced the bending of time, from Earth's satellites to the edge of eternity. The threads of relativity weave a story of clocks, stretched, slowed, and distorted by motion and gravity. Yet, we have only begun to touch the depth, for beyond this lies the question of experience itself. The black hole still waits to teach us what it means to feel time, not just measure it. Every frame of reference carries its own version of time, and near a black hole, this truth is magnified into paradoxes that stretch imagination, yet remain absolutely consistent with relativity. The traveler descending toward the horizon trusts their watch because its ticks remain steady, unaware that a distant observer sees those same ticks drawn out into eternity, almost refusing to arrive. Meanwhile, both realities are equally valid, neither distorted by error, but instead crafted by position and gravity. Two stories that cannot be reconciled but remain individually true. The paradox here is not contradiction, but revelation, for it shows us that time is not universal, but local, flowing differently depending on place and speed. Clocks have always been loyal servants of experience, yet even they bow to curvature when space-time bends deeply. their seconds stretched or compressed without shattering their gears. The seconds on Earth drift differently than those of satellites circling above, where less gravity pulls, requiring constant correction so our navigation systems do not fail. Einstein demonstrated that time and space cannot be separated, for they are woven into a single stage, and mass pushes into this stage until its geometry curves. The truth is humbling, because the seconds we trust as permanent are nothing more than fragile agreements, loyal only to the environment that hosts them. Imagine two twins, one staying safe in calm space, the other orbiting dangerously near a black hole, both convinced their minutes pass normally. The orbiting twin feels heartbeats arrive steadily, muscles relax naturally, and thoughts move with familiar ease. Yet the distant twin grows older by decades while waiting. Yet relativity protects both perspectives, assuring us no mistake has been made, because time itself flows differently along their separate paths, both valid in their own frames. The twin paradox ceases to be confusing here. Instead, it becomes the natural consequence of stretching space-time, which does not ask for our intuition before it acts. Time reaches its strangest character at the photon sphere, that mysterious orbit where light itself runs in endless circles, never able to escape or descend. The photon trapped here cannot outrun the curve, nor surrender fully to the fall, imprisoned by the geometry of space-time alone, without walls, without material barriers. Every ray brushing that fragile line carries evidence of dilation, a story written in its stretched path, proof that even light must submit to curvature. The existence of such an orbit unsettles human intuition, because light feels invincible, yet relativity proves it is bound, obedient to gravity's architecture. Light captured this way creates visions unlike anything ordinary experience could offer. Arcs, rings, and multiplied images swirling around the dark center. The traveler floating nearby sees stars smeared into halos, galaxies doubled and tripled, the sky rearranged into mosaics of distortion born from geometry alone. Stars hiding behind the abyss appear forward, their positions stolen and rearranged, as though space itself folded like a mirror bent too sharply. The sight feels like illusion, but it is truth, a faithful display of relativity's hand upon photons. Accretion disks add even greater drama to this already strange stage. Spirals of dust and gas shredded into heat before plunging inward. The heat is unbearable, because friction tears particles apart as they collide and grind, each losing energy that escapes as brilliant light across the cosmos. Every photon leaving that furnace is stamped with delay, stretched in wavelength by gravity, slowed before it escapes the deep well that imprisons it. From the traveler's perspective, nothing feels unusual. Their seconds align naturally, their breath continues without interruption, and every pulse matches the rhythm of memory. The outside universe, however, runs in fast forward. Galaxies merge, stars collapse, civilizations grow and vanish, all while the traveler believes they have floated for only hours. Civilizations could rise, write histories, and fade into silence without notice, because the local frame of the traveler's time refuses to speed for distant events. The gap is profound, yet it is no illusion. It is relativity, binding each life to its own rhythm without apology. Even the act of waiting becomes unstable near a horizon, for an hour close to the abyss might equal centuries beyond. The meaning of patience collapses into contradiction, because one traveler's pause is another traveler's lifetime, and no reconciliation restores agreement. Imagine the shock of returning after what felt like a day, only to find generations gone, names remembered only as fading inscriptions in history. Such loneliness is not poetic exaggeration, but the arithmetic of relativity, division measured in years instead of distance. Philosophy falters when confronted with these distortions, because past, present, and future depend on consensus, which relativity denies. The words we use for sequence lose power when each observer builds a private order, events shuffling or reversing across frames. Events cannot be forced into one single timeline. They slip across boundaries, revealing cause and effect as fragile companions instead of absolute partners. The story of the universe becomes patchwork, a quilt of perspectives, each honest, each incomplete, stitched side by side, but never seamlessly one. Consider the event horizon itself, the ultimate boundary where paths collapse inward and escape ends. A line of silence, not a surface. The name suggests a wall, but no surface exists, only a geometry that funnels all motion inward once crossed. From outside, the traveller never seems to complete the fall. Their descent slowing until frozen, their light stretched into invisibility. The astronaut feels no interruption. Seconds continue, thoughts remain clear. The moment of crossing passes without notice. Signals betray the difference most clearly. Every photon climbing outward is stretched until it disappears. The observer, waiting afar, hears voices slow into murmurs, deeper, longer, and finally silent, while the speaker inside continues normally. Yet, relativity holds both experiences as true. Two journals kept separately, each a faithful record within its own frame. The contrast shocks intuition, yet it is accuracy. For relativity writes many books of time, none superior to another. Imagine recording the traveller's fall with a camera fixed on the horizon, the lens steady, the frames unbroken. The recording shows their movements stretching endlessly, gestures frozen, descent delayed forever, the traveller suspended on the brink. Even centuries later, the same footage will replay unchanged, a body still hanging near the edge, descent never reaching completion. The traveller inside, however, knows only smooth passage, their seconds untouched, their crossing already finished without hesitation. Relativity honours both sides of the story because no frame dominates, and each observer owns their truth. The problem lies with us because we hunger for one timeline that unifies everything, but the universe never promised such simplicity. Time is not singular, it is plural, written into local rhythms. Each observer correct, each observer separate. The lesson is humility. To know that our truth is never universal, but only local, and that others are equally real. Closer to the abyss lies the singularity, that mysterious place where equations break, where infinity replaces answers and certainty dissolves. The traveller cannot share news from inside. No signal climbs back, no light returns to describe the unknown. Inside, relativity fails, offering infinities instead of numbers, equations that shout limits instead of predictions. The truth is incomplete, for we need quantum physics, a deeper union that may finally describe the center. Beyond the event horizon lies a region wrapped in silence, where signals cannot climb, and where the language of relativity begins to falter at its core. The singularity appears in equations as infinite density, a place where matter is crushed without limit, and space-time itself bends until description collapses. Inside such a realm, time may end, or it may take shapes beyond imagination, twisting into patterns our mathematics cannot yet express. The truth is that relativity guides us only so far, then leaves us staring into an abyss of unfinished understanding. Physicists call this failure a challenge because infinity is not a number but a warning, a signal that the theory itself has reached its limits. The traveler who falls beyond cannot report back. No radio waves climb outward, no beams of light escape, no evidence reaches observers outside. Still, we imagine their perspective, building models to guess. Though each attempt is painted with uncertainty, a sketch rather than a clear portrait, the lesson here is humility, for science must admit what it does not know, even as curiosity burns for answers. Quantum theory may one day carry us further, merging with relativity to create a deeper language, one that speaks both of small particles and heavy gravity. The attempts are many, from string theory to loop gravity, each searching for ways to tame infinities, to replace singularities with structures more complete. Perhaps space-time is not smooth but granular in texture, woven from loops or threads too fine for current instruments to see. The hope is that one day such models will show us what lies beyond, not only mathematically, but through evidence gathered by telescopes and detectors. Meanwhile, we can linger outside the horizon, studying its influence on the world around it. Because even silence radiates truth through effects we can measure. The gravity near a black hole sculpts light, bending beams into arcs, magnifying galaxies behind it, revealing distant structures through gravitational lensing. Every image from such a lens carries doubled stories. The foreground black hole and the background cosmos both stitched together by distorted geometry. The evidence collected in these distortions confirms relativity, proving again that space-time bends precisely as Einstein described. Consider what time feels like at this distance, balanced on the edge of inevitability, where gravity bends clocks so heavily that outside years vanish in hours. The astronaut who waits there sees their own seconds unfold normally, yet in the telescope back home, centuries have already advanced. History may rush past them, entire eras lived and concluded while they hover unaware, believing themselves to have paused for a day. The gap becomes unbearable to imagine. For how can memory survive when experience and reality diverge so deeply? Even the thought of survival grows strange here, because bodies are not only tested by time, but by forces that stretch and compress them violently. The tidal gravity near a black hole becomes uneven. One side of a body pulled harder than the other, creating what physicists call spaghettification. Falling into such a gradient turns people into threads. Atoms stretched in chains, matter pulled longer and thinner until its bonds collapse. The experience may be brief, but the lesson remains clear. Gravity sculpts not only clocks but bodies, and both surrender to its rule. Still, not all black holes kill quickly, for supermassive giants at galactic centers stretch time and space across scales so large that tidal forces weaken near the horizon. The traveler near such a monster may drift through, crossing the boundary with little resistance, though never returning again. Paradoxically, the smaller black holes are far more violent, their gradients sharper, their pull dividing atoms into dust before any crossing. The contrast reminds us that not all horizons are equal, each one telling a slightly different story of destruction and endurance. Scientists turn to cosmic evidence for clues, measuring waves of gravity as holes collide, listening to space-time ripple when giants merge. The detectors, like LIGO, translate those faint signals into sound, a chirp rising in pitch as two black holes embrace and become one. Each chirp is more than noise, it is a clock, a measure of time as space-time itself vibrates, a reminder that these collisions happen in real universes. The future promises more sensitive instruments, capable of hearing deeper, catching smaller mergers, telling us more about the nature of horizons. Imagine civilizations far in the future using black holes as laboratories, building engines and observatories around their horizons to measure time at extremes. The dream is not impossible, for we already use gravity wells of Earth to test relativity through satellites and clocks. Extending that idea outward may someday turn black holes into tools, not threats, places to measure quantum effects where space-time bends most. The vision stretches across centuries, but curiosity does not tire. It waits, it grows, it reaches beyond fear toward knowledge. Philosophy walks with science here because time near a black hole forces us to rethink not only physics, but what it means to live. The moments we call ordinary are not absolute. They are relative, fragile, shaped by environment, and that realization reshapes how we tell our own stories. Even without visiting horizons, the lesson applies, reminding us that every life is lived in a frame, each perspective partial, each valid. The universe does not grant one central clock. It offers many streams, each flowing at its own pace, together composing reality. Returning again to the horizon itself, let us dwell longer, for its silence hides not emptiness, but endless possibility. The event horizon does not crush in itself, it is a marker, the point where escape ceases and the story turns inward. Outside observers can never watch the crossing complete. They see only delay, only stretching, only the fading of signals as they grow longer. The traveler notices no change, no announcement, no line, only smooth continuation, unaware of the finality others imagine. Still, the imagination trembles at what lies further inside, where equations fail, where singularities wait, where geometry collapses into silence. The limits of relativity urge us toward quantum answers. Yet those answers remain just out of reach, sketches and models, not confirmations. Speculation becomes unavoidable, but we must temper it, for the abyss invites fantasies as easily as it invites science. Our task is caution, to wait for evidence, for only evidence transforms wonder into understanding. Even while waiting, the outer universe gives us abundant clues, in gravitational lensing, in delayed light, in waves that ripple space-time. The cosmos itself becomes our instrument, every galaxy with a central black hole providing signals of time slowed and stretched. Each observation tightens our confidence that relativity is correct, that clocks bend, that signals fade, that time is never absolute but always local. The future holds deeper surveys, sharper images, more sensitive ears, and with them, new ways to test time near horizons. Here we pause, not to close, but to breathe with the scale, the realization that time itself fractures into many truths. The traveler near a black hole proves this. their minutes carried normally while centuries escape beyond their sight, ungraspable forever. Outside observers see an endless freeze, a body suspended forever on the brink, never crossing, never returning. The truth belongs to both. Each version faithful to its frame, each reminder that relativity is not theory alone, but lived reality. Falling into the grip of a black hole is not simply a matter of motion, it is an unraveling of both time and body. The forces that shape this descent are called tidal because they stretch and pull with differing strengths across a single form, tearing it apart piece by piece. Imagine your feet closer to the horizon while your head lingers higher. Gravity pulls harder below than above, stretching you longer and thinner as descent continues. The experience has been named spaghettification, a word that sounds whimsical, but in physics, it means nothing less than the destruction of matter itself. Tidal forces depend greatly on the size of the black hole, because smaller ones pack the same mass into tighter curves, producing far sharper gradients. In stellar mass black holes, these gradients rise so violently that a human body would shred long before crossing the event horizon. Supermassive black holes, however, spread their pull across enormous scales, and near their horizons, the stretching is weaker, sometimes gentle enough for crossing unnoticed. The contrast surprises many who imagine larger always means more deadly. But the truth is that survival depends on scale, not only mass. Even if survival is possible across the horizon of a giant, the fate inside remains unknown, because singularities still lurk beyond description. The traveler might drift past the point of no return, yet they could live moments or hours longer, unaware that equations already fail beyond them. Relativity cannot predict what follows after that silent line. It simply admits uncertainty, handing the problem to quantum ideas not yet complete. The truth is both sobering and freeing, for it shows how much remains hidden and how much wonder science still chases. Inside the speculation, quantum physics attempts to soften singularities, perhaps replacing infinities with loops, strings, or grains of space-time too fine to see. The dream is that unification will reveal structure, a way to describe what lies within without surrendering to impossible infinities. Perhaps black holes could even be bridges between regions, wormholes hinted at by mathematics, though none yet proven by evidence. The ideas multiply as equations are explored, but caution reminds us to hold back, because theory must meet observation before belief is earned. Meanwhile, the regions outside horizons remain fully observable, giving scientists endless tools to measure and confirm what relativity already promises. The waves of gravity produced by black hole collisions ripple space-time outward, and detectors on Earth have now caught their faint signals directly. Each ripple marks the union of giants, turning motion itself into measurable sound, the rising chirp of cosmic bodies falling into one another. The fact that these ripples were detected proves relativity again, and promises that we can listen further, deeper into the universe's heaviest events. Accretion disks also act as open windows, their violent light and high-energy emissions speaking clearly of matter shredded near horizons. The radiation we measure across X-rays and gamma bursts comes from these disks, heated into brightness as particles collide and spiral inward. Every flicker carries information about the curvature near horizons, the delays, distortions, and frequencies all pointing toward relativity's rules etched across space-time. The cosmos, tells its story through these luminous signals, and with each observation our confidence grows that gravity bends time exactly as Einstein said. Even daily life reflects these truths in smaller scales. Satellites and clocks already remind us that relativity works. The seconds on orbiting satellites tick faster than ground clocks, their height lessening gravity's hold, and corrections must be made for accuracy. Without these adjustments, our systems for navigation would fail within hours, proving relativity not only cosmic but practical. The fact that daily technology relies on these principles makes the larger cosmic effects more believable, the extraordinary validated by the ordinary. Now, imagine standing near the photon sphere, where light circles the abyss, the view unlike anything else in the universe. The traveler sees stars curved and multiplied, arcs of galaxies bending across the sky, halos surrounding the dark center like glowing crowns. Every direction holds distortion because geometry itself is bent, and the eye records truth even when the brain struggles to interpret it. The vision is haunting, yet it is mathematics made visible, the bending of space itself painted in light. Civilizations of the far future may build observatories near such edges to watch time slow and measure extremes directly. The concept is not fantasy because science already places instruments into challenging orbits, following gravity's pull to learn more. Perhaps one day black holes will be tools, laboratories for quantum gravity, where answers to singularities and mysteries emerge. The path to such futures is long, but curiosity is patient, and humanity has always reached further when imagination calls. Philosophy must keep pace with physics here, because time stretched and fractured changes how we think about life itself. The moments we hold as absolute turn relative, different for each observer, different for each path through gravity's embrace. Even without visiting black holes, the lesson applies, reminding us that our truth is partial, always shaped by frame, never absolute. The humility this demands may soften human perspective, making us more willing to honor truths beyond our own. Stories of black holes often emphasize terror, but science whispers something gentler, that even extremes can be understood, even chaos can be studied. The astronaut falling inward is not torn immediately in every case. Sometimes they pass smoothly, proving survival is possible for longer spans. Still, no journey returns because horizons divide signals forever, and the inner truth is locked away beyond evidence. The mystery endures, yet not as failure, but as invitation, asking us to listen harder, measure sharper, imagine deeper. Closer than horizons, equations tremble into silence, the singularity defying all current models, presenting infinite density where understanding collapses. The limit of relativity is here, at points where infinities replace measurable values and predictions no longer hold. Quantum physics may one day resolve this crisis, offering grains, loops, or strings to describe structure instead of chaos. The truth waits, but until then we hold questions, not as failures, but as signs that knowledge still has places to grow. Listening to gravitational waves is only the beginning, for new detectors will soon stretch sensitivity, catching smaller and more frequent mergers. The future will give us maps of black hole populations, their sizes, their spins, their histories written in ripples of space-time. Each discovery will deepen our picture, turning speculation into clarity, turning theory into observation. The cosmos offers patience, and science must mirror it. waiting for faint signals that take billions of years to arrive. Even as theories evolve, our imagination must move carefully, because black holes tempt us with metaphors too easily. The word spaghettification makes destruction sound whimsical, yet the process is as severe as any violence in physics. Stretching matter into threads is not poetry. It is the reality of gradients too steep for bonds to survive. The lesson is to respect terms without losing rigor, for behind every playful word lies a serious truth. Gravity is both sculptor and storyteller, and near a black hole it shapes both space and time until they become almost unrecognizable. The traveler who lingers close may see the universe age and change in fast forward, while they remain untouched in their own minutes. Outside observers watch them freeze in motion, their descent halted at the edge, never reaching completion. Both perspectives stand equally correct, each reminding us that time's truth is plural, not singular. Here, we linger longer, breathing with the scale. The weight of knowing time fractures into countless local truths. The traveler accepts their minutes as steady, their pulse as constant, yet the universe betrays them with centuries slipping away elsewhere. Outside telescopes confirm the stall, the image of their body lingering eternally, light stretched until invisible, never crossing. The truth belongs to both, and it belongs forever. Relativity carving its rules into every frame without compromise. Every exploration of black holes eventually drifts toward energy because their pull is not only a prison for matter, but also a furnace, capable of releasing staggering power. The jets launched from their poles are among the brightest signals in the universe, blasting radiation across millions of light years, fueled by swirling disks of shredded gas. From these regions, entire galaxies can be lit, their cores blazing brighter than all surrounding stars combined, a single point commanding cosmic attention. The fact that destruction produces such illumination reminds us again, endings and beginnings in the cosmos are often intertwined, indistinguishable at the edges. Accretion disks act as cosmic laboratories, their light carrying the signature of time stretched and space bent, a record of matter's final screams before surrender. The particles heated there move near light speed, colliding violently, glowing fiercely, and sending radiation outward that astronomers catch with orbiting telescopes. Every photon bears the stamp of dilation, a story delayed by gravity, slowed in its climb, stretched as it escapes the abyss. The disk itself is a teacher of relativity, its flickering rhythms translating equations into visible, measurable patterns of truth. Jets rise perpendicular to disks, narrow streams of energy, and they extend farther than entire galaxies, threading through intergalactic space like cosmic needles. The mechanism that powers them remains partly hidden. Magnetic fields, spinning matter, and curved space-time together producing something not yet fully solved. Still, their presence confirms the strength of gravity's engines, because nothing short of black holes appears capable of creating such focused, lasting beams. The sight of jets reveals the paradox again. Places of collapse simultaneously producing pillars of order, broadcasting energy outward with precision. Even without approaching horizons, the evidence of dilation is already measurable. Our instruments detect shifts in light and time as signals leave black hole neighborhoods. The wavelengths of radiation reveal the slowing of clocks. Lines stretched redder than expected, signals delayed beyond predictions from simpler Newtonian ideas. Every spectrum is a confession of relativity, each measurement confirming equations written over a century ago by Einstein. The truth is now routine, but no less wondrous, for cosmic confirmation continues daily, assuring us that space-time bends exactly as described. Now, consider what living near such regions would mean, not only physically but psychologically, for time itself would feel untrustworthy. The traveller might settle in orbit near a giant hole, feeling ordinary minutes, while beyond their station centuries pass unchecked. Returning to familiar places would confront them with gaps, loved ones aged beyond recognition, societies transformed, history rewritten beyond their experience. The shock of dislocation would be immense, proving that survival near such objects demands not only strong ships, but stronger minds. Philosophers have wondered how memory would cope with such gaps, when continuity is stolen and personal experience no longer matches the wider world. The moments you lived remain intact, yet their context dissolves, leaving you anchored to a timeline now isolated from everyone else's. Perhaps cultures of the far future will build rituals, ceremonies to anchor travelers who return from relativistic journeys, reconnecting them gently with new histories. The lesson is that physics reaches into psychology, showing us that time dilation is not only technical, but deeply human. Still, these human stories remain speculative, for our current missions circle only weak gravitational wells, nowhere near black hole horizons. The tests we perform use satellites and atomic clocks, precise but limited, enough to confirm relativity, not enough to reshape lifetimes. Yet progress is relentless, and each generation pushes instruments closer to edges, preparing for observations in harsher gravitational neighborhoods. The future of exploration may indeed involve horizons, not for visiting, but for watching carefully, listening as their signals sharpen into clarity. Observatories already orbit Earth, designed to collect light beyond human sight, X-rays, gamma rays, and infrared waves, all whispering from cosmic furnaces. The patterns we decode reveal temperatures, velocities, and densities, pieces of puzzles that together map the environment near black holes. Every bit of data is another thread, a filament woven into the tapestry of understanding, one more confirmation that relativity rules. The task of astronomy is patience, allowing faint photons to build stories across years until truth emerges from accumulation. Gravitational wave astronomy is younger but no less promising. A new ear opened to hear space-time itself ripple. The chirps detected so far come from collisions of giants, brief but powerful, the final heartbeat of merging black holes. Each signal provides measurements of mass and spin, fingerprints of objects invisible to telescopes, revealed only through space-time's trembling. The promise is that more sensitive detectors will soon hear quieter songs. Smaller mergers, more frequent ripples, subtler truths waiting in silence. Imagine centuries ahead, when humanity has settled among stars, when explorers build entire colonies around safe orbits near supermassive black holes. The reason would not be thrill, but knowledge, using horizons as laboratories, clocks, and engines to test physics at limits. Communities might anchor themselves to stable orbits, living in distorted time, aware that their decades equal centuries outside. The choices they face would redefine life, raising questions about identity, continuity, and belonging across fractured timelines. Ethics would evolve with science here, because travelers leaving such colonies could never return unchanged, their personal ages betraying them against home societies. The cultures might establish rules, deciding when to depart, when to stay, how to reconcile lives split by dilation. Even families could divide by choice, some remaining in steady timelines, others venturing into distorted ones, forever separated by time. The cost of science becomes clearer. Not only equipment and energy, but human bonds reshaped by relativity. Still, the fascination grows, because black holes carry answers to physics questions, uniting relativity with quantum puzzles, perhaps rewriting entire foundations of science. The singularity hides secrets about matter, whether it compresses infinitely or transforms into something new beyond current language. Quantum mechanics may supply the bridge, showing us that space-time is not continuous, but built from grains or loops too fine for current vision. The hope is that one day we can test this, observing signatures in light or waves that confirm the structure inside. Meanwhile, supermassive black holes govern galaxies, holding stars in orbits, stabilizing cosmic cities across billions of years, not only destroyers but architects of order. The mass of such objects correlates with galaxy size, suggesting that stars and black holes grow together, influencing each other's history. Every galaxy we see carries such a heart, from spirals like the Milky Way to ellipticals stretching vast distances. The truth is that black holes are not rare. Even our own Milky Way carries one, a supermassive presence called Sagittarius A, resting at the center, 4 million times the mass of the Sun. The observations made of its motions confirm relativity again. Stars whipping around in visible nothingness, their paths bending as if pulled by a hidden hand. Images from the Event Horizon Telescope gave shape, showing the shadow ring of Sagittarius A, a direct view of space-time distorted. The moment of that discovery was profound, proof that what theory described truly exists. Still, mysteries remain even here. Questions about how Sagittarius A feeds, how jets form, how matter behaves so close to horizons. The efforts continue with sharper arrays, more telescopes combining into networks, eyes stitched across Earth to improve vision. Each improvement promises clearer shadows, brighter arcs, sharper rings, finer confirmation of relativity at extremes. The future holds more such images, not only of our black hole, but of many others across galaxies. Even now, as we drift in thought, the edges of knowledge feel both close and far, within reach, yet always slightly beyond. The traveler falling inward remains silent, their story unfinished, their perspective lost behind the veil. Outside, we listen, collect photons, catch waves, piecing together what we can, content that partial truths still reveal beauty. The cosmos whispers its secrets slowly, and we move slowly too, matching patience with patience. Every deepening of our journey into black holes returns us to questions of survival, not only survival of matter and energy, but survival of information itself. The laws of physics declare that information cannot be destroyed. Every particle's history must remain embedded somewhere, even when matter itself collapses beyond recovery. Yet when matter falls beyond horizons, its story appears erased. Light fails, signals vanish, and history seems swallowed without return. The paradox of information loss challenges both relativity and quantum physics, forcing us to confront contradictions at the very edges of knowledge. Stephen Hawking brought this puzzle into sharp focus, showing that horizons are not perfectly silent, but instead radiate faint energy, now called Hawking radiation. The idea shook physics because it meant black holes evaporate slowly, bleeding energy until they eventually vanish entirely, leaving nothing visible behind. Every black hole, no matter how vast, carries this destiny: to shrink over unimaginable spans, to fade away instead of lasting forever. The trouble is that when they vanish, the information once inside appears gone, contradicting the laws that forbid true erasure. Quantum theory resists such erasure, insisting that information must remain encoded somehow in the radiation or the fabric of space-time itself. The search for resolution has filled decades of debate, whether information leaks slowly outward, hides in correlations, or survives on the horizon itself. Perhaps the event horizon acts like a screen, storing data about everything that enters, projecting it faintly outward as radiation escapes. The concept of holography grew here, the universe itself perhaps functioning like a hologram, with three-dimensional reality stored on distant two-dimensional boundaries. Even if holography holds truth, our understanding remains partial, for no experiment yet confirms where information truly resides. The mathematics provides consistency but not evidence, offering coherence to theories but leaving direct observation absent. Still, progress continues as physicists test analog systems, building black hole mimics in laboratories, using sound waves and fluids to reproduce horizon behaviors. The hope is that simple models may reveal patterns, hints about how radiation encodes data, how disappearance avoids contradiction. Consider the scale of Hawking evaporation, how long it takes for black holes to fade, far longer than the current age of the universe. The giant at our galaxy's center would require more than 1060 years, an incomprehensible stretch of time before disappearing. Even smaller stellar holes demand trillions of years, making their evaporation irrelevant to present cosmic history, though vital to ultimate fate. The lesson is that Hawking radiation matters not for immediate astronomy, but for reconciling physics itself, linking relativity with quantum law. Meanwhile, the cosmic environment around black holes continues shaping galaxies, controlling starbirth, influencing growth, anchoring spiral arms with invisible weight. The link between central holes and galactic evolution is now clear, as their masses scale directly with the size of surrounding stellar systems. Every galaxy carries this bond, suggesting that black holes and stars grow together, partners across billions of years. The relationship is intricate, but it proves that horizons are not only ends, they are also beginnings, architects of order on galactic scales. Imagine the Milky Way without its central giant. Stars might scatter differently, arms less stable, formation less orderly. The presence of Sagittarius A defines our core, a silent anchor around which the entire disk revolves. Though we cannot feel its gravity here, its influence remains essential, shaping orbits across tens of thousands of light years. The truth is that our very stability owes debt to an object most people will never see, but which dictates structure regardless. Still, the role of black holes expands beyond anchoring. They serve also as engines of transformation, quenching star formation through their powerful winds. The jets, streaming outward, scatter gas, heating and dispersing the raw material needed for new stars, halting birth across entire regions. Paradoxically, destruction prevents creation, yet this restraint stabilizes galaxies, preventing uncontrolled bursts of star birth that would exhaust resources quickly. The balance is delicate, and black holes play guardians as much as predators, regulating life cycles on cosmic scales. Even our concept of time's arrow bends here, because evaporation suggests black holes change over unimaginable ages. The thought that giants shrink is unsettling, yet it aligns with entropy, the universe's tendency toward greater disorder. Still, the mechanics remain uncertain. No telescope has lived long enough to witness shrinkage directly, leaving us with equations alone. The future of this research may rest with new detectors, instruments capable of catching faint radiation that betrays evaporation's beginning. Imagine how civilizations might use such knowledge, hawking radiation as a source of power, building engines around horizons to harvest fading heat. The idea of black hole farming feels fantastical, but physics does not forbid it, and distant futures may see it attempted. Every watt of energy escaping carries information embedded, and in principle that stream could fuel machines, ships, or colonies. The vision stretches beyond millennia, but curiosity always plants seeds of futures far ahead of present needs. Philosophy circles back, asking how identity survives when time diverges across frames, when seconds mean different things in different places. The traveler orbiting a horizon believes in continuity, but their continuity splits from the universe, carving a timeline that no longer matches any other. Even language strains. For how do we speak of simultaneity when simultaneity ceases to exist across frames so deeply divided? The answers may never satisfy entirely, but the questions force us into humility, a trait both science and philosophy require. Still, the fascination persists, because black holes concentrate mystery like no other objects in the universe. The astronomer sees their influence on galaxies, the philosopher sees their paradoxes, the dreamer sees their metaphors. Every perspective finds meaning, whether in equations or imagination, because horizons represent edges and humans are drawn to edges. The truth is that they are not only cosmic engines, they are mirrors of our need to understand limits. Even as we explore, our tools refine slowly, building clarity year by year. The Event Horizon Telescope gave us direct images, shadows of Sagittarius A and M87, rings of fire around silence. Those pictures confirmed theory, confirmed relativity, confirmed that predictions match what nature reveals when instruments sharpen. The moment was profound. Proof that ideas born from chalkboards describe reality billions of light years away. Future arrays will sharpen that vision, combining more telescopes, pushing into finer wavelengths, revealing horizons with greater detail. The dream is not only sharper pictures, but dynamic ones. Movies of disks flickering, matter spiraling, time dilation visible frame by frame. Every improvement deepens confidence in relativity, while opening doors for new surprises, anomalies waiting beyond predictions. The cosmos rewards patience, and horizons test patience most of all. Even as instruments grow, imagination must grow too, because equations alone cannot satisfy our hunger for meaning. The stories we tell about horizons are not lies, but extensions, metaphors that carry truth into human language. Still, caution is needed, for too much poetry risks misleading, turning physics into myth rather than science. The art is balance, letting metaphor guide curiosity without erasing precision. Here, we pause again, not to end, but to breathe, to notice how deep into paradox and possibility we have already travelled. The traveller still hovers near horizons, their seconds steady, while galaxies outside continue rushing forward through centuries. Outside observers still watch, their images freezing, their footage showing endless delay. The truth remains plural. One fall, many versions, each correct in its frame, each beautiful in its strangeness. Every exploration of horizons eventually confronts extremes of matter itself, because the behavior of atoms near crushing gravity becomes as mysterious as time dilation. The particles that normally define structure cannot resist endless pressure. Electrons squeezed, protons collapsing, familiar arrangements erased under relentless density. Physics predicts these conditions exceed anything inside stars, anything in laboratories. Yet they remain beyond our reach, hidden from experiment. The truth is that singularities press deeper than our current equations can survive, exposing cracks in theories once thought complete. Inside neutron stars, we already glimpse the threshold. Densities so high that nuclei pack tightly, forming exotic states of matter unseen elsewhere. The step from neutron stars to black holes crosses limits. A tipping point where even neutrons cannot bear the pressure, collapsing without resistance. Beyond that threshold lies uncertainty, a realm not captured by relativity, not modeled accurately by quantum mechanics, not explained fully by any known law. The lesson of this boundary is humility, a reminder that not all mysteries can yet be solved. Still, speculation helps shape the path forward. Quantum theories attempt to smooth infinities, suggesting grains, strings, or loops underlying space-time's fabric. The idea that reality has smallest units fascinates, because it means curvature near singularities may not collapse infinitely, but stop at quantum scales. Perhaps singularities hide a new phase of matter, not destruction but transformation, a rearrangement that remains hidden only by our lack of tools. The task is to refine these models, until evidence speaks clearly, confirming which sketches mirror truth. Even without entering horizons, we see their fingerprints. Quasars blazing across billions of light years, powered by supermassive black holes. The light they emit carries patterns of relativity, showing time slowed, signals stretched, photons escaping reluctantly. Every quasar is both a lighthouse and a laboratory, guiding astronomy while proving equations against distant ancient tests. The fact that such distant objects match relativity is staggering. Einstein's ideas survive scrutiny across the cosmos. Galaxies reveal the partnership between stars and central holes, their growth intertwined, their histories inseparable. The motions of stars prove hidden masses, invisible yet massive, bending paths without light. Measurements of these orbits refine estimates of black hole sizes, millions to billions of solar masses resting at centers. The universe shows us these anchors everywhere, confirming that black holes are not rare accidents, but common features of galaxies. Still horizons are not only massive, but also dynamic. They grow as they consume matter, merge with each other, expand their influence. The mergers we detect through gravitational waves prove this growth, the chirping signals mapping histories written in space-time. Each wave that reaches Earth confirms collisions, two horizons becoming one, their masses combining, their spins altering. The evidence of such unions reshapes astronomy, letting us chart cosmic families invisible otherwise. Even time itself feels heavier after such mergers, because space-time trembles when horizons unite. The ripples spread outward, carrying away energy, leaving behind quieter, larger black holes. Every detected wave is both music and measurement, the universe singing its heaviest events through faint vibrations. The task of detectors is patience, listening constantly, waiting for rare chirps among silence. Imagine standing safely in orbit near such events, watching time unfold. Seconds local to you, centuries rushing far away, ripples carrying histories beyond reach. The traveler here confronts relativity directly, their clocks loyal, yet the cosmos around them racing beyond recognition. Even imagination struggles to capture this gap, minutes beside a black hole equaling eras elsewhere. The lesson again is that time is plural, personal, fragmented, never absolute. Philosophy finds echoes of this truth in daily life, where perspectives diverge, where personal rhythms never align fully. The idea that universes of experience differ is not foreign, but gravity makes the difference extreme. Even memory cannot reconcile such gaps. A traveler returns to futures they never lived, pasts they never saw. The weight of such distortion forces reflection, not only on science, but on identity itself. Still horizons do not erase wonder, they amplify it, for even silence teaches. The edges of black holes reveal laws, bending, twisting, challenging, but never breaking the logic of relativity. Every paradox is a doorway to deeper questions, inviting exploration rather than closing it. The truth is that confusion often signals discovery, proof that limits of knowledge have been reached. Even our tools today are blunt, yet progress sharpens them. The arrays of telescopes catch shadows, direct images of horizons once thought impossible. Those rings confirm relativity in detail. Shadows matching predictions, arcs glowing as matter falls. The images are crude now, but refinement will come, and with it clearer vision. Future networks will expand further, more telescopes, more frequencies, more clarity. The dream is dynamic movies, horizons filmed over hours, light bending visibly, disks flickering frame by frame. Every advance deepens relativity's proof and widens possibility. Anomalies may lurk, details may surprise, but truth grows sharper. The cosmos waits for us, patient, immense, unchanging to its own rhythms. Even daily life confirms relativity's whispers. Satellites, clocks, navigation systems correcting for dilation. The ordinary proves extraordinary rules, confirming that time is not constant, not universal. Every phone call, every map, every signal carries Einstein's imprint. The truth hides in plain sight, cosmic laws shaping mundane minutes. Still, the abyss of singularities calls louder, unanswered, unsettled, waiting. The future of physics depends on this union, relativity and quantum joined, infinities dissolved, structure revealed. Perhaps, horizons hide new dimensions. realities folded beyond perception, explanations waiting beyond imagination. The promise is discovery, but only through patience, only through evidence, never through haste. Here, we pause again, not to close, but to breathe, to sit with the scale of paradox stretched before us. The traveller still circles horizons, their seconds faithful, while outside centuries escape like sand through unseen clocks. Outside we listen still, catching faint ripples, faint photons, faint clues of truth. The cosmos carries on, silent but speaking, distant but intimate, patient but persistent. Every time we circle deeper into the subject of black holes, the theme of horizons emerges again, not simply as physical boundaries, but as boundaries of knowledge. The traveller who hovers near such a horizon remains trapped within their own seconds, steady, familiar, unchanged, while centuries unravel elsewhere without pause. Meanwhile, distant observers continue to witness endless delay, the fall frozen in their telescopes, an image never completing, never crossing, always suspended. The paradox holds both accounts as true, because relativity never promised one rhythm, it promised many, all faithful within their frames. Inside the region beyond lies silence, for signals cannot return, leaving only speculation. The ideas carried there by theorists include singularities, quantum bridges, or hidden dimensions, all attempts to tame infinity. Still, none are confirmed, each remains a sketch on chalkboards. Intriguing but fragile, untested against evidence, waiting for proof beyond mathematics. The truth is that the horizon marks not only the end of escape, but the beginning of ignorance where models fracture. Even before crossing, time is distorted heavily, years outside reduced to minutes near horizons. The traveller may circle in stable orbit, experiencing steady clocks, while civilizations beyond grow, collapse, and vanish across generations. Every return would mean dislocation, the loss of belonging, homes transformed, languages altered, identities scattered across centuries. The cost of exploring such depths is not only risk of destruction, but risk of returning to futures unrecognizable. Philosophy lingers on this possibility, questioning whether identity survives when memory stretches across centuries skipped. The traveller remains themselves, yet their context dissolves, the familiar replaced by strangers, the past unreachable except through archives. Even memory feels fragile here, a series of moments preserved but stripped of continuity with the larger world. The lesson is that time dilation is not only physical, it is psychological, cutting bonds as surely as distance. Still, not all is loss, for horizons also reveal order. Geometry itself drawn visibly in light. The rings imaged by telescopes confirm predictions. Einstein's mathematics written clearly across billions of light years, visible through arcs of glowing matter. Every observation strengthens relativity, each measurement carving away doubt, leaving only confidence in equations once doubted. The truth of horizons is not only silence, it is clarity, for they confirm gravity's deepest rules with precision. Gravitational waves extend this clarity, vibrations of space-time caught by vast detectors buried beneath Earth. The chirps heard as black holes merge confirm collisions, ripples carrying fingerprints of masses, spins, and histories written into trembling geometry. Every detection expands our map, proving that horizons do not live alone, but often unite, reshaping the cosmos through violent marriages. The evidence is growing, and each new ripple caught makes horizons less abstract, more real, more familiar, more measured. Even with these confirmations, mysteries remain, especially the question of information. The laws of physics forbid destruction, but signals from within appear erased, lost to observers forever. Stephen Hawking proposed radiation as a faint escape, particles leaking outward, slow evaporation replacing eternal silence. The problem is that radiation seems random, carrying no imprint of what was lost, defying quantum rules. Quantum mechanics demands that histories remain encoded, that every particle retains its story, no matter how transformed. The search for where this information resides continues, theories ranging from holographic horizons to hidden correlations in radiation. Perhaps the boundary itself is the ledger, storing data in surface area rather than volume, projecting outward faintly across time. The concept reshapes cosmology, suggesting the entire universe might function holographically, dimensions encoded on boundaries we cannot see. Still, confirmation is absent. Telescopes cannot yet test these claims, and experiments remain limited to analogues, water waves, or sound mimics of horizons. The progress remains slow, yet persistent. Each attempt edging closer to clarity, each idea narrowing possibilities. Every failure is not wasted, for it eliminates wrong paths, guiding attention toward what might remain. The patience demanded here mirrors the patience of horizons themselves, vast, slow, indifferent to our urgency. Imagine civilizations harnessing these principles, building power stations around fading holes, extracting energy from Hawking radiation. The idea seems distant, yet physics permits it, at least in principle, a survival strategy for far futures. Every watt of escaping energy could fuel machines, ships, or colonies, heat harvested from collapse itself. The vision is both unsettling and inspiring. Destruction transformed into resource, endings transformed into beginnings. Even today, black holes serve as teachers, reminding us that certainty is always local, never absolute. The frames of observers differ, their clocks diverge, their stories contradict but remain valid. Every lesson from relativity insists on humility, that truth is plural, perspectives coexist, and no single rhythm rules all. The cosmos is not one clock, it is many, all ticking honestly in their places. Still, there are moments of unity, glimpses where horizons connect us, when gravitational waves ripple through entire galaxies, felt everywhere. The mergers of giants remind us of shared stories, that even in plural timelines, events can echo universally. Every ripple felt on Earth is the same ripple felt anywhere, a truth across frames, binding diverse observers briefly. The reminder is that cosmos grants both diversity and unity, fragments and wholeness stitched together. Here, we linger again, holding to this paradox of plurality and unity, breathing slowly with its implications. The traveler still hovers near horizons, their seconds steady, while galaxies beyond accelerate through centuries. Outside observers still see frozen descent, images endless, frames uncompleted, always waiting. The truth remains plural, never singular, never simple, but always honest within its frame. Every horizon reminds us that reality bends when gravity dominates, not only bending light and matter, but bending the meaning of continuity itself. The traveler who nears such a place holds their seconds steady, yet their story fractures from the universe, drifting into a private flow. Meanwhile, the outside cosmos moves without pause. Galaxies merge, stars collapse, civilizations rise and fall, all while the traveler counts only minutes. The paradox lies not in contradiction, but coexistence. Two rhythms unfolding honestly, each correct, yet never reconcilable. Inside the mathematics, singularities still stand as warnings. Infinite density appearing where relativity can no longer guide. The truth of such infinities unsettles physicists, because infinities signal not physical places, but breakdowns in theories themselves. Quantum approaches attempt repair, proposing strings vibrating, loops connecting, grains composing space-time at scales invisible. The hope is that unification will tame infinities, revealing structure where collapse appears absolute. Still horizons reveal lessons even without crossing. Their disks of light and heat teach us relativity daily. The patterns observed in X-rays and gamma bursts confirm that matter's fall is slowed and stretched before vanishing. Every flicker in these violent signals becomes proof, a stamp of dilation etched into photons. The evidence is abundant, gathered patiently by telescopes orbiting Earth, translating collapse into measurable light. Gravitational waves expand the classroom, ripples in space-time carrying histories of mergers across billions of light-years. The detectors listening underground record faint chirps, rising tones that mark collisions too distant for sight but real nonetheless. Each detection is a direct witness, vibrations of the very fabric beneath galaxies. The fact that we can now hear space-time tremble proves how far human patience can reach, instruments capturing whispers of giants. Even the role of black holes in galaxies expands perspective, for they are not only destroyers but architects. The correlations between central masses and galactic size reveal deep partnership, growth entangled across billions of years. Every spiral arm and stellar distribution owes stability partly to horizons hidden in the dark. The truth is that cosmic order relies upon collapse, absence shaping presence, silence defining sound. Imagine the Event Horizon Telescope sharpening further, resolving movies instead of still shadows. The dream of watching light flicker around horizons feels close, not distant, as instruments multiply. Every sequence of frames could reveal motion slowed, time dilation painted clearly in arcs of brightness. The cosmos waits with patience, and we must match it with decades of careful building. Still, the human meaning must be considered, for dilation near horizons forces questions of identity. The traveler who returns after hours may find centuries gone, their homes altered beyond recognition. Even memory cannot bridge such gaps, for while their moments are intact, their context is erased. The lesson is sobering. Time near black holes may be survivable, but belonging may not. Philosophy mirrors physics here, because our stories rely on shared sequences, yet relativity denies global agreement. The order of cause and effect is stable locally, but across frames it shifts, bending with geometry. Every narrative of the universe becomes plural, patchwork stitched from perspectives that never merge. The humility required is great, to accept many truths without demanding one master version. Still, horizons remain fruitful teachers because they test every equation, every law. The observations of bending light, delayed signals, and frozen images confirm predictions again and again. Even Hawking's proposal of radiation extends lessons, reminding us that horizons are not eternal, but fade across vast times. The paradox of lost information continues, unresolved but rich, a frontier where physics must grow. Quantum mechanics insists that information is never erased, that histories must remain encoded somewhere. The theories include holographic principles, suggesting that horizons are ledgers storing every fall. Still, proof is distant, our evidence incomplete. But mathematics insists coherence will be found. The task is patience again, to test faint signals, to refine ideas slowly. Imagine distant civilizations harvesting fading horizons for energy, farming Hawking radiation as fuel. The concept sounds fantastical, yet physics allows it in principle. Every particle of heat released could be captured, powering engines, sustaining colonies, fueling endurance beyond stars. The vision stretches into trillions of years, survival tied to collapse rather than creation. Even without such futures, the lesson of horizons endures. That time is local, plural, flexible. The seconds we count are anchors only for us, not for others. Every life flows in its own frame, trustworthy but not absolute. The truth is plurality, relativity written not only in equations, but in existence itself. Here we breathe again, not closing but resting, sitting with the paradox stretched wide. The traveller near horizons remains steady in their minutes, while galaxies beyond carry centuries outward. Outside observers remain fixed, their images frozen, their telescopes never recording completion. The cosmos offers both silence and clarity, both strangeness and precision, both limits and openings. Every step deeper into this journey reveals that black holes are not only cosmic furnaces, but also profound teachers, forcing us to reconsider what permanence truly means. The traveller who lingers near a horizon feels only steady minutes, but those minutes detach from everything else, leaving behind futures they cannot witness. Meanwhile, the universe outside rushes onward. Galaxies collide, stars collapse, and histories rewrite themselves, all while the traveller remains still within their private frame. The lesson is not destruction alone, but the fragility of shared continuity when gravity bends time. Inside the mathematics, infinities still stand unresolved, the singularity waiting as a crisis, pointing to gaps in theory. The truth is that relativity cannot survive alone. Quantum mechanics must enter, weaving small with large, precision with curvature. Physicists speak of strings, loops, or hidden textures, proposals to replace infinities with structures more complete. The hope is that such frameworks may one day describe horizons fully, giving shape where silence now reigns. Still, evidence outside horizons remains strong. Matter spiraling inward, disks glowing, jets blasting through galaxies. The signals we catch across X-rays and gamma rays confirm dilation, bending, stretching, slowing. Every photon that escapes carries memory. Its frequency shifted, its timing altered, its path bent into new routes. The data builds into portraits of gravity, each one reinforcing relativity's reliability. Gravitational waves extend our reach further, ripples in space-time carrying entire histories of mergers. The chirps recorded by detectors match predictions, proving black holes not only theorized but real, common, and active. Every detection is a triumph of patience. Instruments listening silently for faintest tremors across the Earth. The truth grows firmer with each wave caught. The cosmos continues confirming the logic of Einstein. Even the paradox of Hawking radiation adds to this wonder, suggesting horizons are not perfectly dark but faintly glowing. The idea of radiation means holes shrink, slowly bleeding energy until they vanish. Every fate written here takes trillions of years, far longer than current stars will live. The lesson is ultimate impermanence. Even giants fade, even horizons die. Still, the greatest puzzle is information. For physics forbids destruction, yet signals within appear lost. The search for solutions has birthed holographic principles, suggesting horizons act as ledgers, storing data across their surfaces. Perhaps every fall is written faintly on this ledger, projected outward through subtle patterns of radiation. The concept stretches imagination, the entire universe itself perhaps holographic, its depth encoded on boundaries. Even if true, proof eludes us. Experiments cannot yet test such claims. The progress is patient, ideas refined, analog models built in laboratories, imitating horizons with sound or waves. Every trial reduces possibilities, narrowing paths toward truth. The cosmos forces humility, demanding decades for even small clarity. Imagine civilizations in distant futures using these truths, building engines around horizons, harvesting faint heat. The concept of farming black hole radiation feels unreal, yet physics allows it. Every particle escaping carries energy sufficient to sustain colonies across unimaginable spans. The vision reminds us that destruction itself could one day sustain life. Endings turned into beginnings. Still, the immediate role of black holes is galactic, anchoring stars, stabilizing structure, regulating growth. The links between their masses and galaxies prove partnership across billions of years. Every galaxy carries such a core, from spirals to ellipticals, each one defined partly by collapse. The truth is that black holes are not rare curiosities. They are common, essential, universal. Even our Milky Way holds one, Sagittarius A, a supermassive anchor millions of times the Sun's mass. The observations of nearby stars confirm it, their orbits bending around invisible presence. Every pass confirms relativity's equations, arcs aligning with predictions precisely. The shadow imaged by telescopes sealed proof, the ring of absence visible across the cosmos. Still, the psychology of horizons cannot be ignored, for they reshape human concepts of time. The traveler who orbits briefly may return to centuries past, their own body unchanged, their world unrecognizable. Every bond risks breaking across such gaps, memory intact, context erased. The lesson presses inward. Physics is not only external, but deeply human in consequence. Philosophy leans into this realization, questioning identity when continuity fractures. The idea that time itself is plural unsettles narratives, for our stories assume linear flow. Even simultaneity cannot survive across frames, cause and effect bending differently in each. The truth is patchwork. Many timelines coexisting, stitched into a quilt too vast for one version alone. Still, horizons offer beauty beyond paradox, for their distortions paint the sky with arcs of light. The traveller circling near sees stars doubled, tripled, bent into crowns, galaxies warped into halos. Every photon bent this way tells geometry's story, a language of curves written in brightness. The vision is haunting, yet it is science, not illusion, truth spoken by photons. Even destruction holds elegance. Spaghettification stretching bodies into threads beneath steep gradients of gravity. The forces, tearing one side harder than the other, write violence into matter, reducing it into dust. Every small black hole produces death quickly, its gradient too sharp for survival. The giants, however, allow smoother entry. Horizons passed without immediate tearing, survival possible longer. Still, the end remains. Singularities claiming whatever crosses. The uncertainty lies in the how, whether infinities persist, whether matter transforms into unknown states. Quantum theories whisper of hidden structures, grains of space-time preventing true collapse. The evidence waits for us to find, faint signatures yet unseen. Even as physics works patiently, imagination expands, filling gaps with visions of futures. The dream of using horizons as tools inspires engineering, even if centuries away. Every challenge sparks new questions, ensuring curiosity never tires. The cosmos answers slowly, but it always answers piece by piece. Here, we drift again, breathing with the vastness, accepting plural clocks, fragmented truths, unfinished models. The traveller remains steady in their minutes, the universe remains patient in its centuries. Outside observers still see frozen descent, images never finishing, signals stretched to silence. The truth remains layered, paradox and clarity intertwined, mystery and measurement side by side. Every journey eventually arrives at reflection, and after circling black holes through many perspectives, we can finally ask what they mean for life, what they mean for us. The traveller who floats near their edge embodies the paradox, their own seconds unfolding normally, while the universe outside rushes beyond recognition. Meanwhile, the observers who watch from afar record a frozen image, descent suspended, clocks refusing to align, frames locked in contradiction. The truth is that both views are valid, and within that validity lies the lesson of plurality, humility, and perspective. Inside these paradoxes rests the ultimate reminder. The cosmos is not built to match intuition, but to surprise, to stretch the imagination wider than comfort allows. The rules of relativity and quantum mechanics meet here, at horizons where equations falter, where infinities rise, where patience demands answers still unknown. Even if singularities remain unresolved, their existence reveals that our science is not final, that our understanding is incomplete, and growth is inevitable. The lesson of horizons is that the universe will always be larger than certainty, larger than one perspective, larger than one story. Still, the evidence we do possess is remarkable. photons escaping disks, waves rippling space-time, arcs of light bending perfectly according to Einstein's geometry. The images of M87 and Sagittarius A confirmed predictions, showing shadows and rings where nothingness itself bends light. Every signal caught from these regions validates relativity's precision, mathematics describing structures billions of light-years away with accuracy. The truth is that the universe obeys its laws faithfully, even when those laws strain our comprehension. Gravitational waves added new instruments to our reach, detectors that catch tremors of merging giants. The chirps heard so far prove collisions, black holes uniting, masses combining, histories written into ripples carried outward. Each detection offers a new kind of map, population surveys of horizons otherwise invisible, families of giants counted through sound. The fact that space-time itself vibrates reminds us the cosmos is not silent, but musical, vast, but expressive. Even more extraordinary is Hawking radiation, the faint glow that implies horizons are not eternal. The idea that black holes evaporate, losing mass across trillions of years, unsettles assumptions of permanence. Every star dies eventually, and even the giants that consume them fade, not eternal, but impermanent. The future of the universe may be ruled by this slow decay. Horizons shrinking, galaxies darkening, silence spreading. Still, within impermanence lies hope, because endings always open into beginnings. The radiation imagined by Hawking might sustain civilizations, heat harvested from fading giants, survival stretched beyond starlight. Perhaps distant futures will orbit shrinking embers, extracting energy patiently across eternity. The vision reminds us that destruction can serve creation, collapse can feed survival. Philosophy echoes loudly here because horizons do not only bend physics, they bend meaning. The traveler who returns to futures they never lived teaches us that time is not shared universally. Even memory and identity fracture when seconds diverge, when personal continuity detaches from the flow of civilizations. The lesson is compassion, to accept that others live in frames different from ours, perspectives equally valid, equally true. Still horizons offer beauty beyond paradox, because their distortions create skies unmatched anywhere else. The traveler near the photon sphere sees stars bent into halos, galaxies tripled, arcs stretched across darkness like mosaics. Every photon bent here is a word in geometry's language, space-time writing visible poetry in light. The vision is haunting, yet it is mathematics revealed honestly, truth displayed across the sky. Even destruction carries wonder, spaghettification showing us the violence of gradients. The forces that stretch bodies remind us of gravity's unrelenting sculpting, beauty and brutality inseparable. Every fall reveals new limits, testing the strength of matter, pressing it into threads. The lesson here is respect, for extremes do not yield, they demand recognition. Still, the role of black holes extends across galaxies, anchoring stars, guiding structures, regulating growth. The relationship between their masses and galactic size proves they are architects as well as destroyers. Every galaxy bears such a core, spirals and ellipticals alike. The truth is that collapse builds order, absence shaping presence. Even our Milky Way carries its silent anchor, Sagittarius A. The motions of nearby stars confirm it, arcs bending faithfully around unseen presence. Every orbit is a proof of relativity, predictions matched by real paths. The images captured gave faces to theory, turning equations into shadows visible to human eyes. Still, mysteries remain, especially inside horizons, where equations fail, where infinities resist. The quantum solutions sought may describe structures hidden from sight, grains, loops, or strings. Perhaps space-time itself has smallest units, preventing infinities, offering clarity. The promise of unification continues, patient, unfinished, hopeful. Even as models grow, imagination stretches wider, asking if horizons connect to others, wormholes bridging regions. The mathematics suggests such gateways, though no evidence confirms them. Every speculation feeds curiosity, reminding us that science and wonder are partners, not enemies. The truth is that gaps in knowledge are not failures, but invitations to continue. Still, the human connection is what grounds all of this, because we are not separate from the cosmos, we are part of it. The atoms in our bodies were born from stars, forged in furnaces before the Earth itself existed. Every second we live is a cosmic gift, borrowed from billions of years of prior histories. The lesson of horizons is therefore intimate. They remind us of scale, but also of belonging. Even when distant, black holes are part of us, their presence in galaxies shaping our home. The future of astronomy will bring sharper images, richer maps, better detections. Every improvement deepens our confidence, while also opening space for surprise. The cosmos never stops teaching, and horizons are its most insistent lessons. Here we draw slowly to our end, not abruptly but with quiet gravity, letting the scale settle in. The traveller remains suspended in imagination, their seconds ticking faithfully while universes outside continue centuries beyond. Outside observers remain frozen with images of delay, their telescopes recording descent never finishing. The truth is that relativity gives both stories equally. Time is not singular, but plural, not absolute, but lived. Even as we close, the mystery remains. Horizons still silent, singularities still hidden. The future of science is unfinished, equations incomplete, experiments waiting, instruments growing. Every generation builds upon previous, each pushing further into shadows, each demanding answers. The cosmos rewards patience, and patience is infinite. Still, the deepest lesson is humility, because horizons show us that certainty is rare. The truths we hold are local, partial, tied to frames, never universal. Every perspective is honest within itself, yet incomplete in totality. The lesson is to embrace fragments, to accept plurality as beauty, not failure. Here our narration rests gently after drifting across paradox and wonder, collapse and clarity. The traveller fades back into imagination, their minutes steady, their story unfinished. Outside telescopes still listen, still watch, still wait. The cosmos continues patiently, vast, silent, eternal, to its own rhythm.